Welcome. In this video, let us refer to some terminologies and be aware that our purpose is to get familiar with how to describe our feasible set later. Let S1 to be the set that contains points x1, x2 in R2 such that x1 squared plus x2 squared is less than or equals to 1. All the points in this set belongs to R2. Therefore, we say that this set S1 is a set in R2. This collects all the points in the disk center at the origin 0, 0, and the radius is less than or equals to 1. So, it contains points which is inside the circle and including the boundary. And we use the vector x to represent the points x1, x2 in R2. Example 2, we have the set S2 which contains points in R2 such that x1 plus x2 is less than or equals to 1. And we also say that S2 is a set in R2. Example 3, we have the set S3 which contains points in R3 such that x1 squared plus x2 squared plus x3 squared is less than or equals to 1. We say that S3 is a set in R3. This set contains points which lie on the sphere with center at the origin 0, 0, 0 and radius equals to 1, as well as points inside the sphere. And we can denote the vector x to be the points in R3. Example 4, we have a set which contains points in Rn, the n-dimensional space, such that these points satisfy this constraint inequality with the expression g of x1 up to xn less than or equals to a constant. Then we can say that this set is a set in Rn. Finally, we have the fifth set which contains points in R2 such that both they satisfy x squared plus y squared less than or equals to 25 and x plus y is less than or equals to 3. This is a set in R2 and those points contained in this set S5 are points on the yellow region. A set is regarded as an open set if it doesn't contain any of its boundary points. For example, the set that contains all points in R2 such that x squared plus y squared is less than 1 is an open set because it only contains points within the inner part of the disk with radius less than 1 and with origin 0, 0, but it doesn't include points which lies on the boundary which is x squared plus y squared equals to 1. A set is a closed set if its complement is an open set. For example, the set S which contains points on R2 such that x squared plus y squared is less than or equals to 25 is a closed set because its complement will be another set which contains points in R2 such that x squared plus y squared is greater than 25. And this set will be an open set because it doesn't contain the boundary points which lies on x squared plus y squared equals to 25. Next, the set S which contains points in R3 such that x1 squared plus x2 squared plus x3 squared is less than or equals to 9 is also a closed set because the complements of this set which contains points in R3 such that x1 squared plus x2 squared plus x3 squared greater than 9 does not include the boundary points which locates at x1 squared plus x2 squared plus x3 squared equals to 9. This set contains points on the sphere with center at the origin and radius equals to 3, as well as points inside the sphere. Another interpretation of open set is that a set S is open if for any element x in this set S there exists a small ball of elements in S surrounding it. We can see that for the set S that contains points in R2 such that x squared plus y squared is less than 1, it is an open set because for any elements in this set, I can always find a small ball which are filled with some other elements in S surrounding this point. For example, if I take the point which locates at here, negative 0.9990, there will still be points on the x-axis which is between negative 1 and this point, negative 0.9990. Those points are still within the set S. Therefore, I can form a small ball containing elements in S that surround the selected green point here. I can do so for any other points in the yellow region. Therefore, this set is an open set. However, it is not the case for the set S which contains points in R2 which satisfies x squared plus y squared less than or equals to 25. Among those points on the circumference of this disk, that is, those points that fulfills x squared plus y squared equals to 25, suppose I pick the point at the location negative 5, 0, then this point is on the circumference of the disk and it is an element in S. But there is not any more points which has an x-coordinate less than negative 5 which belongs to S anymore. So we cannot find any small ball which is filled with other elements in S surrounding the point negative 5, 0 that locates at the circumference of the disk. Therefore, this doesn't fulfill the condition to be an open set, and in fact, the complement of this set is an open set. Therefore, this set is a closed set.